So here we are in Fluent now, and the mesh that we created in the meshing portion of the setup has been brought in here. And if we just show you the setup that we had to go through to get the thing running. So one of the first things that we did was we turned gravity on in the simulation, and we set the gravity magnitude and direction to minus 9.81 in the y direction, which is down in this particular simulation. And then we checked the mesh, and no problems were found there. So we've run the check there and no problems have come up. And then the next thing that we did was we defined the models, models that we were going to use. We defined a multi-phase model, which was the volume of fluid multi-phase model, which we'd used in the tutorial earlier. And we defined the number of phases as 2, which is the air and the water. And we turned implicit body force on, which we'd done in the tutorial for the dam break simulation. We changed the viscous model from laminar to K epsilon because we were expecting some turbulent effects to be happening behind the boat, so we didn't think that it was a laminar situation. We imported the water liquid from the Fluent materials database. The air fluid was already loaded in, so we didn't need to do that. And then we set the two phases. We set the primary phase as air and the secondary phase as water, and we gave them an extra label just so that we could identify them more easily later on. And then we systematically went through setting all the boundary conditions up. So you can see the blue line here is representing a velocity inlet, well, two velocity inlets, one for the air and one for the water. The velocity speed was set at 5 meters per second for the air and 15 meters per second for the water. The two outlets were set as pressure outlets, and the top of the geometry and the bottom of the geometry here were set as planes of symmetry, and then the two interfaces were set as interfaces. The interfaces were then defined. So the air interface was linked to the water interface. And then the solution methods were set as they were set in the dam break tutorial. As were the solution controls. They were just set to the values that were advised in the dam break tutorial as well. We turned on print and plot the residuals just so we could monitor them as it was calculating, and then we initialized the solution and patched the water volume fraction in the water portion of the mesh to 1, so that it was 100% water. Next, we created a command to execute every 20 time steps, and we defined a macro which would plot the volume fraction in each cell on the screen. So that's the volume fraction of water and air, and then save a screenshot of that with a function in the name of the screenshot that allowed consecutive numbers after the screenshots, so that we got a consecutive run of screenshots that we could then stitch together into an animation of what was going on in the simulation as time progressed. So then we set the time step size, which had to be considerably smaller, an order of magnitude smaller, as it happens, than the dam break tutorial. We suspect that this was because of the large difference in cell size between the cells very close to the hull and the cells around the boundary. And then we set the number of time steps to a good healthy number, which was 100,000 in this case. And then we ran the calculation.